Hi, and welcome back to another video. And in this lesson, we're going to go over chapters 8.1, hypothesis testing for statistics. Now, a little disclaimer, I just got some dental work done and I have a somewhat of a lisp. So, just bear with me on that. Or feel free to laugh if you catch me lisping. Anyway, let's go ahead and get started with this. All right, so number one says a formal hypothesis test is to be conducted to test a claim that the wait times at a Space Mountain ride in Walt Disney World have a mean equal to 50 minutes. Okay, what is the null hypothesis and how is it denoted? Okay, so with null hypothesis, you're always going to need your H0 or H sub 0. Null hypothesis, null means 0, N-U-L-L, null. Basically, and this is how you're going to set it up each and every time. So we're talking about means here, right? So you want to use your mean symbol. All this other stuff right here, you may recognize those other symbols, standard deviation, stuff like that. We're sticking with the mean this time, okay? So with the null hypothesis, you're always in this course, you're going to use an equal sign, okay? So equal to what? It's whatever your claim number is, and what I refer to the claim number is more than likely it's going to be in the same sentence with the word claim in it, literally. Like, so this is the only number we have to work with. It says the claim equal to 50. So look, it's just equal to 50. Okay, so and you're going to see we're going to be doing this often. All right, nice work. Okay, what is the alternative hypothesis and how is it denoted? Okay, the alternative hypothesis will be H1. In some cases, I've seen HA. Remember, these are subscripts. The 1 is a subscript, so they may say H sub 1 or H sub A. But either way, you're still going to use the mean symbol here. And this one is basically, depending on what they say, they can say, what's the claim of something being less than a number, greater than a number, or equal to a number, or different from a number, or something like that. You're going to choose the equal sign with the slash. So you see the claim says that Walt Disney World have a mean equal to 50. Well, we already used the equal to. It was obligatory that we use the equal to symbol with the HO. So if the claim is talking in terms of equality, use the cannot equal to sign, the equal to sign with the slash. And the claim number is what we put here, and it's still going to be 50. The claim number does not change. Okay, what are the possible conclusions? You're either going to reject the null. It's very important that you say reject the null hypothesis, or you're going to fail to reject the null hypothesis. You notice that they're giving an emphasis on the null hypothesis portion. So fail to reject the null and reject the null hypotheses. All right, so far so good. All right, is it possible to conclude that there is sufficient evidence to support the claim that the mean wait time is equal to 50 minutes? In this chapter, I hate to say it, they're going to play a lot of word games with you. If you're good with linguistics and other good stuff, and you're going to be okay. But let's see if we can get to the bottom of this. The answer is no, by the way. Let's see. Hypothesis tests can only find sufficient evidence to support a claim when a claim contains equality. Let's see. Hypothesis tests can only find sufficient evidence to support a claim when a claim does not contain equality. Hypothesis tests can never find sufficient evidence to support a claim. They can only find sufficient evidence to warrant it. No, it's not going to be D. I can tell you that much. Let's see. This not really. We're going to go with this one. Let's see. Hypothesis test can only find sufficient evidence to support a claim that the claim does not contain. Yeah. I believe this is 100% true. Make the most sense out of it if you can. Try to wrap your head around it. I'm more of the mathematics, but you're going to see as we get further in, you're going to get more of an understanding of it. Okay, let's go ahead and do another version. Okay, the Erickson method. Let's see. Several You guys can read it right. In a clinical trial, results could be analyzed with the formal hypothesis test. Alternative hypothesis, P is greater than 0.5. See, this time they're talking about proportions. They're not talking about means this time. There's a distinction, and you're going to see as we progress, it'll become more apparent. Which corresponds to the claim that the method increases the likelihood of having a girl, so that the proportion of girls is greater than 1/2, which is 0.5. If you have an interest in establishing the success of the method, which of the following p-values would you prefer? Okay, I'm going to tell you right now, the one that you're going to prefer is the smallest p-value. And you're going to see that when we're testing claims, when your p-value is less than your significance level, you're going to reject the null hypothesis, which means that you're going to basically support the claim. So you want that p-value to be very low, and 0.001 is the lowest as they come. So compared to the others, right? Because we have so many of these choices, you want to choose the smallest one, and it's that one. Let's see, it's preferred because it corresponds to the sample evidence that most strongly supports the alternative. Remember, you reject the null, which means you're supporting the H1, the HA, the H sub 1, or the H sub A. Let's see. The method is effective whenever you reject the null. That means you're supporting the H1, which means that you're saying that there is enough evidence. And we're going to write it down so we can get more acquainted with it. There we go. Nice work. Let's do this one again. Okay. Let's see. Express the original claim in symbolic form. So I'm just going to go ahead, just like in the last example in chapter 7. I'm going to skim for what I need. It looks like they have the word claim here. So whatever follows it is going to be our claim and the number that we should use. So it says more than 4.2% of homes have a landline telephone and no wireless phone. This is going to be in terms of P, all because they're using percentage. Remember, proportion, percentage, they tie in together. They're not using means like the last time, right? So we're definitely going to be using P. So it says more than 4.2. So more than, we're going to use the greater than symbol. Remember the greater than symbol, if you take your right hand and opening it up this way towards yourself, that stands for greater than. Less than is your left hand opening up this way and looking at it. So that's the way I like to remember. Okay, and what's the number we're going to use? This is 4.2%. So remember, let's use our calculator here. Let's use it. Okay, so we have 4.2. Remember, to change a decimal into a percentage, remember, like, for example, let's say 100%. If you want to change it to a decimal, you divide by 100 and you get one whole, right? It's the same thing right here. If we have 4.2, if you want to change it to a decimal, which is what we really need, divide by 100, you get 0.042. You can also just move that 4.2 to the left 2 places. So yeah, either way. So we're going to go ahead and choose, we're going to go ahead and enter 0.042. And we get a good job. So now we're going to take this claim that we put in symbolic form over here. We're going to take it and branch it off into these two guys here in terms of null and alternative. So once again, you're going to use P for both. The HO will always in this course be an equal to sign. In other courses, I've seen it not be an equal to. And, well, I've seen it be greater than or equal to or less than or equal to. But for some reason, all the courses are built differently. And I prefer this course over the other ones that I've experienced. HO will definitely agree with whatever your original claim was. I'm sorry, H1 will agree with what your claim is. HO will always be equals. So H1 is going to be greater than, just like the claim says, more than 4.2. So you better choose a greater than symbol. Okay, and whatever your claim number is from the previous step, you're going to put the same thing here. So we have 0.042, and that's it. All right, same thing here. Let me see. here's a claim. The mean systolic or systolic blood pressure of the. Okay, so automatically, I'm going to go ahead and choose the mean symbol. Okay, less. So we're just going to go run over to the less than symbol. Less than what? 125 millimeters of Hg, which is mercury for you science buffs. Okay, that's our claim number. Excellent. Okay, so in terms of HO and H1, HO, we're gonna choose the mean symbols for both of them. HO will have an equal to sign without the slash. Is always just a regular equal to sign. All right, no funny business. H1 will agree with whatever our original claim was, which is less than, and we're going to use the same number. So 125 and 125. Okay, claim fewer than, so less than, in other words, fewer than 96% of adults have a cell phone. In a reputable poll of 1,125 adults, 86% said that they have a cell phone. Find the value of the test statistic. So we're going to use a calculator. So we're going to use our TI-84 to solve this one. So what do we need? Well, there's a calculator function for this. We go to stat, we go over to tests. And now, depending on what we have here, depending on if we are dealing with means or dealing with proportions, we have a specific test for that. So are we dealing with means here? No, we're not dealing with any means. We're dealing with an actual percentage. So this is going to be a proportion, a one prop. So instead of using z-test, which is what we would have used if we had means, we're going to use one prop z-test. Okay, so now look at this. They're asking you for your p sub 0 this time. Normally we would have h sub 0, right? But don't worry, it's all the same thing. They're just using a different letter to specify the type of test that we're doing. Anyway, this is p sub 0, the claim number. I always call this number the claim number. And what is our claim number? Well, they said that fewer than 96% of adults, right? That's your claim number. So we're going to go ahead in the decimal form, put 0.96. Remember decimal form, when you're putting numbers in the calculator, you want to use a decimal just to be absolute sure that you get your answer correct. Now it's asking us for an X and an N. It says fewer, so let's go ahead and hit enter on the less than symbol. Now, what about these guys? What is our X and what is our N? Well, if you recall from the passage, it says we have a reputable poll of 1,125 adults. So our sample size is 1125. So let's put 1125 right here. Now, what is our X? They gave us a percentage, right? They said that 86% said that they have a cell phone. So we have to figure out what is 86% of our sample size. What's 86% of 1125? And here's how you do it. To find a percentage of a number, you take that percentage as a decimal and you multiply by the number. And this is a calculator. You can do calculations here. Why not? It's a calculator. It knows where and when to calculate, and it calculates everywhere. So let's go ahead and multiply. We're going to hit enter and we're going to have to round. So it did it for us. And we always want to round to the nearest number. If you, I believe you're allowed to round to the next. We're gonna get it right. So we're gonna put an 8 here, round it to the nearest whole number, and we have 968. And we should be good to go. When you hit calculate, you get all of this stuff right. You see, we have z is equal to negative 17.04. That is your test statistic. Down here, you see your p is equal to 0. That is your p value. Very important. This p hat here is basically the percentage of your sample size. And if they ask us for p hat, hey, they'll give it to us right then and there. It's your x divided by your n. Yeah, we're good. Let's go ahead and put our answer in. And we ended up getting, how many decimals they want? They want 2 decimal places. And it's a negative. Z-scores can be negative, as you know. That's what a test statistic is. A test statistic is a Z-score, 0.04. And we got it. Nice work. Okay, so knowing how to use your calculator functions using one prop z-test and z-test, that's basically what chapter 8 is about. Of course, they can tweak it and add different things, but you know, we can be prepared for it. Don't worry. What is the value of the test statistic again? So they're talking about standard deviation, which means that they're going to be talking about means in this problem. So we're going to go ahead and use the z-test, but let's get what we need first. Let me see. I'm going to take the calculator and I'm going to put it over here, like somewhere in the middle. I hope you guys can see that when the video's editing or done editing. All right. I'm sure you will. Okay. So what do we have here? Test the claim. Da, 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 da. All right. So let's go to the calculator function. Since we know we're using means, let's exit from here. You can hit clear, stats, test, z-test, and it's asking us if we have data or statistics. We don't have data. We don't have a list. If we did, we'll just go here to data, put in your L1 and call it a wrap, right? But we have actual statistics. We have the standard deviation and the mean and everything like that. So all you do is put the numbers in. So what is your claim number? Well, it says to test the claim. Let's see, the mean systolic blood pressure of all healthy adults is less than 120. That's your claimed sentence. That is your claimed number. So this is 120. What is your standard deviation? Standard deviation, do you see it right there? 14.91. What is your mean? Let's look for it. It says the mean systolic blood pressure is 119.58. That's it. 119.58. What is your sample size? Sample size 260 healthy adults. You can see it right there. 260. You see, I'm just skimming for everything. This may not be the best practice, but you know, you want to scrutinize everything. Remember, reading is fundamental. But I've done this quite a few times, and you know, I'm prone to mistakes as well. So it may happen. It's gonna happen statistically. I'm gonna make at least one mistake in one of these videos. Anyway, but it's not the end of the world. As long as we know what we're doing at the end of the day, that's all that matters, right? Okay, the last sentence, the null and alternative hypothesis are, okay, so they were nice enough to give us our H sub 0, which is our null, and our H sub 1, which is our alternative. And we're going to use 120 as our claim number here. So remember, in your calculator, whatever your H1 is, that's what you want to put in your calculator, okay? So they're using a less than symbol, so we're going to use a less than symbol. And let's go ahead and hit calculate. And that's it. That's everything we need. So your test statistic is whatever your Z is. So this is negative 0.45. They wanted 2 decimals and got it. Nice work. All right, next. Let me go ahead and just get this wrong. Yeah, this hurts my soul just a little bit. Oh, close. You know what? Let's hit help me solve this. And then when you exit out, it's going to give us a brand new one. I don't know why I didn't think of it. Anyway. Okay, the test statistic is Z is equal to 1.62. And this is obtained when testing a claim that the P is greater than 0.3. Identify the hypothesis test as being two tail, left tail, or right tail. So let's go back to, let me close this out. Let's go back to describing what a left tail or right tail is. So when they start talking about tails, they're talking about the actual graph itself. So you know, you have 3 scenarios. Okay, so you know, you have 3 little histograms. Don't judge my art. Or you can judge my art. It's up to you. Okay. Okay, okay. So over here we have a left tail. You know, this shaded region right here, they call this the critical region. And for you people, for you guys that are testing without the calculator, this may be helpful. It will be helpful. This is for left tail. You can see the tails on the left. Down here, this is your right tail. And you can see your tails on your right. This is for when you have a, this is for when your H1 is greater than some number. Up here is when your H1 is less than some number. And over here, you have a two tail. And this is when your H1 is not equal to some number. So yeah, you can see that less than, whenever you're using an equality symbol, whether it's not equal to or equal to, it's neither less than or greater than, right? Or you can say it's both less. Well, that wouldn't make any sense, but little luck. A two-tail test, a two-tail will always have the equal to symbol or some other variant. Okay, right tail greater than, left tail less than. I hope that wasn't too messy, but that's the idea. Okay, so how does that apply to us, what we have right now? Well, we have a greater than symbol, right? So that's going to correlate to a right tail test because greater values are always to your right. All right, so this is a right tail test. Well done. What is the p-value? Now, you might want to write this down. Okay. Your p-value, depends on your test statistic. So, very important. Now, the calculator has been spitting out this test statistic for us the whole time. So you see right there at, hold on, you guys can't see. Okay, so you see right here where z is equal to negative 0.45. It gives you a p-value directly underneath it. So if they ever ask you for p-value, there it is right there. All right, the 0.32 portion. And basically what they do is they put it on your histogram on your x-axis, and they calculate the shaded region. They do do you remember the normal CDF from chapter 6 and N7? It's the same deal. So it's the shaded region depending on that test statistic. So yeah, we're gonna have many more examples in the future, so don't sweat the small stuff. But anyway, back to the question, what is the p-value? So we're gonna go ahead and use our trusty calculator. The calculator is very helpful in this section. It's dire that you know these shortcuts and everything like that. All right, so stats. Now, are we using a z-test or a one prop z? They gave us in terms of p, so this is a one prop z-test, p prop. Okay, what is the claim number? The claim number is going to be, it says greater than 0.3, so that's our claim number, so 0.3. Oh. Okay, Claire, let's put 0.3. What is our x? Oh, the thing is, remember when I just told you that the p-value is dependent upon your test statistic? So listen, we already have everything we need. They didn't give us an x, they didn't give us an n. We have everything we need for the test statistic. All we have to do is use a different function. You may recall from the last chapter that we use the normal CDF, and that's exactly what we're going to use here. So what is your lower, your upper? Let's go back to, let me make the histogram for you guys so you can get an idea of what's going on here. Okay. So we know this is a right tail test, right? And you know we have a histogram like so. It says greater than, so this is right tail. and we have a shaded region over here, and it's like, what is this? That is your test statistic. Your test statistic here is going to be 1.62. This is a z-score, so you know your mean is 0, your standard deviation is 1 by default in this case, in terms of z. And to find your p-value, which is this shaded region right here, so this is the p-value. It's like, how do we find the area of a shaded region? Normal CDF. So we basically take the normal CDF of 1.62 all the way to infinity, make your mean 0, standard deviation 1, and we'll have it. So let me put the calculator back up for you guys. There we go. All right, so let's go ahead and handle some business. Okay, so your lower is going to be, oh, well, let me make sure that you guys know what I'm doing. Hit second vars, normal CDF. We're going to choose our lower as being the test statistic because to the left of that shaded region, we have 1.62. So go ahead and put your 1.62. The upper is infinity, which is just, you can just put a bunch of 9s like that. Your mean is 0 because we're dealing with the z-score. Standard deviation is 1 because we're dealing with the z-score. Hit enter, enter, and there's your p-value right there. How many decimals? They wanted 3 decimals. So this is 0.053. So 0.053. And that's it. That's your p-value. All right. So we weren't able to use the 1PROP-Z test this time because they were nice enough. I guess they were generous enough to give us the test statistic, but they're not always going to do that. But if they do, you know, you're going to use the normal CDF function, right? Okay, so what is the conclusion? How do we get to the nitty-gritty of testing? How do we know if we're going to support a claim or not? Simple. If you're using a calculator, all you have to worry about is if your p-value is less than your significance level. Significance level. There goes that dental work at work. All right, so when your p-value is less than your sig level, oh, can you see? Yes, you can. All right, so when your p-value is less than your significance level, they call it alpha, which, you know, we call sig level. We'll call sig level. When your p-value is less than your sig level, you're going to reject. When your p-value is greater than your significance level, you fail to reject. We'll put FTG. Fail to reject. Oh, you can't see that right now. Let's see. Let me take myself away. FTG. All right. Yeah. So what is our p-value? Our p-value is 0.05, right? Is 0.05 less than or greater than our significance level? Well, what is the significance level? Their significance level, the alpha, is 0.01. Is 0.05 less than 0.01? No, it's greater than. And because it's greater than, we're going to fail to reject. So this is a fail to reject because it's greater than. Whenever you fail to reject, there is not sufficient evidence. And that's it. I'm going to write better notes for you in the future. Like for right now, we're going to do this a little bit better. Let's help me solve this. Exit out. Okay. Let's see what kind of test this is. We have an equal to with a slash that stands for cannot equal to or does not equal to. This is a two-tail. Okay, p-value. P-value is going to be dependent on your test statistic. And now here is a really, really good example on what to do when we have a two-tail test. It's slightly tricky, just ever so slightly tricky. All right, so you know we have our fancy little histogram right here. We have our two tails. Okay, and you know they're shaded. This is what they call the rejection region. Actually, this is not the rejection region. We'll get into that in the future. We'll get into that later. Okay, so what do we need from here? It says that we have a two-tailed test and we need to find the p-value. So you can imagine if we have 2.37 right here. Let's say this is 2.37, right? Whatever you get for your p-value. So we're going to figure out what that is. This right here is your p-value. So is this one. So if you can get your hands on this portion here going in this direction, this shaded region, you're basically going to multiply by 2 to get this other shaded region over here. And you have to add all the shaded regions together. So whatever you get when we do your normal CDF, you're going to just take that answer and multiply it by 2 because it's in 2 different areas, 2 different spots, 2 sides of the histogram. So whenever you have a two-tailed test, you have a little funny business going on. You can commit it to memory, I promise. Just remember 2 tails, you need to account for 2 different areas. Or I should say 2 of the same areas. All right, so let's do it. Second vars, normal CDF. What is our lower? What is our upper? Your lower is going to be wherever your test statistic is, so 2.37. Because remember, we're calculating from here all the way greater than, all the way to the right. So we're going to choose infinity again, which you can just put a bunch of 9s. Mean is 0, standard deviation is 1, hit enter. Now this is your p-value for just one of those shaded regions. But remember, this is a two-tailed test, so make absolute sure that you multiply your answer by 2. So now we have both shaded regions, and there it is. So they wanted 3 decimal places. So let's go ahead and turn off the calculator. Sorry, give me 1 second. All right, off the calculator. And 3 decimals, so we have 0.018. There it is, fantastic. Okay, now what can we conclude? Remember, we're going to test this p-value against the significance level. So remember, when a p-value is less than your sig level, you're going to reject. Another thing, when you reject, there is enough evidence to support the claim. Whenever you take your p-value and it's greater than your sig level, this is the alpha. That's what a significance level stands for, alpha, whatever. You're going to fail to reject. So FTR, fail to reject. And there is not enough evidence to support the claim. So just remember these 2 little guys here. When your p-value is less, there is. When your p-value is greater, there is not. When it's less, you reject. When it's greater, you fail to reject. And really, it's so consistent with the later chapters. And if you commit that to memory, you're gonna do very well. So what is our p-value again? Our p-value is 0.018. So is that less than or greater than their sig? So we have 0.05, 0.01. Our p-value is less than the significance level here, right? So when it's less than, we're going to reject. So it's either going to be C or D. Now, is there or is there not? Whenever you reject, there is. And that's it. Okay, I'm moving right along. Critical values. Now, you only find critical values when you're using what's called the traditional method. The traditional method doesn't call for us to use the calculator. And actually, that's a different way of finding claims, or testing claims, I should say. And I think maybe I should go over it. Let's see if they're going to make us. If they make us go over it, because I'm very, very pro calculator, if you haven't realized, because the technology was made to make our lives easier, right? Let's see what they got going on here. It says find the critical values. Well, let's write this down right quick. You remember how the p-value depended on your test statistic? Your critical value, which is another z-score. You can write this down for your notes. Your critical value depends on your significance level. So it's like you have to know which goes which. Embed this into your memory, write it down, because on your exam it will pop up. Even though we don't really use the critical value when we're testing claims because we have a calculator in this case, but you never know when they might force us to. I'm not sure how can they force our hand, but you want to be prepared. But anyway, whenever they're going to ask you about critical values, okay, it depends on your sig. And it's going to be the same routine. However, the significance level, if you may recall, the significance level is it's a percentage. So you're not going to use normal CDF because you actually have an area, you have a percentage, you have a shaded region. You're going to use inverse norm. So let's go ahead and see what we got here. Find the critical value. Let's see. This is a less than, so this is a left tail test. So remember, we're going to have, whoops. All right, so remember, we're going to have, give me 1 second. Yeah, so we're going to have something that looks like this. Something like that. And now that we're here, if you recall me saying before about this being called the critical region, yeah, the critical region is specifically for the critical value. I started to say that it was for the test statistic shaded region, but nah, this is definitely for the, now we can more accurately call this a rejection region. And since we're here, I'm going to explain what that's all about in a second. Okay, but this little area here, now we have an actual area, and that area is going to be whatever your significance level is. So this is actually the 0.05 from the passage. This is your alpha. So we want to figure out what this guy here is, the number that separates the left side from the right side. And to figure that out, you may recall from chapter 6 and chapter 7, we're going to use the inverse norm function in our calculator. So let's go to TI-84. To get to inverse norm, we're going to go to second vars. We're going to go all the way down to inverse norm. The area that we need is the area to your left. Remember, your calculator wants the areas to your left. Excuse me, the area to the left of what you're looking for. So we're going to just put the 0.05 in there. Or 0.05 is the same thing. Keep your mean as 0, keep your standard deviation as 1, hit paste, and bam, there it is, negative 1.64. How many decimals did they want? They wanted 2 decimals. And you see we have A and B. They're asking us how many critical values do we have with left tail and right tail. You only have one shaded region for both of them, right? It's either left or right, one shaded region. So that's going to only have one critical value. For your two tails, you guessed it, your two tails will always carry 2 critical values. So 2 tails makes things a little bit more complicated, but don't worry, you're a mathematician in the making. You'll be done with this course soon, and hopefully this will be your last math class if you hate math. All right, anyway, I don't know why I said that. Anyway, this is only going to be one critical value, and it's going to be negative. Yes, the signs matter in this case. So let's go ahead and put your negative 1.64. And we got a good job. Should we reject the HO or should we fail to reject the HO, which stands for null hypothesis? I'll tell you this. I know we've gotten so accustomed to using the calculator, but you know what? Knowing the traditional method, which is what this is, using histograms and knowing where everything is placed, using the traditional method is not too bad, and I'll show you why. We just figured out that this number right here is negative 1.64, right? If you want to figure out if you're going to reject or fail to reject, we're going to need another number. We're going to need our test statistic. And it's like, where is our test statistic? We have negative 1.58. That's what they say our test statistic is. Now, with respect to the significance levels critical value, which is 1.64, which is also a z-score, by the wrong color, which is also a z-score, we're going to compare the test statistic z-score to this one. But where would that lie? The test statistic z-score is negative 1.58, right? With respect to negative 1.64, is it going to be to the left or to your right? Well, remember, if you recall your number line, remember you have 0 in the middle. And if you have something like 1/2, like negative 1/2 over here, and you have negative 1/4 over here, it's consistent, right? Sorry about that. It's like because it's in decimal form, it's a lot easier to grasp. I know normally 1.64 would be greater than 1.58, but because we're negative, the negative 1.58 is going to be somewhere to the left. So listen, just imagine your negative 1.58 is like right over here somewhere. Now, question to you, is this negative 1.58 inside the rejection region, this little blue area right here, the shaded region? If the answer is no, you failed to reject. It's not underneath that umbrella. So this is definitely a fail to reject. And the reason why we're rejecting is because it's not inside the critical region. So let's see. The HO should not be rejected. That's true. So it's either going to be A or B. And the reason why is because it is not in the shaded region. And this is the traditional method, which is a little technical. It can be done. I'm not saying that you can't do it, but we prefer the technology, right? All right, next. Find the critical value. Critical value depends on your sig level. Let's go ahead and do that very quickly. And remember, you can always rewind. Okay. What do we have here? All right, the critical value depends on your sig. This is a two-tailed test. A two-tailed test depending on our sig. So let me make a histogram so you can get in the right mindset. We're gonna have two of these guys. Okay, now here's the tricky part. Remember, two-tailed test makes things a little bit more mathematically tricky, right? Now, we have a significance level of 0.10, right? Problem is, they're in two different areas, two different positions. So you're going to have to divide that significance level by 2, and that's it. So let's take our 0.10, divide that thing by 2, so that we can get 0.05. The 0.05 is what's going to be here. And that's also located here. So, we have two different areas on two different sides of the histogram. Where do we go from here? How do we get the critical values? Well, I'm glad you asked. So let's go to our calculator. All right, it's on. We're going to do inverse norm like we did in the last example. So let's go to inverse norm. The area that we need is going to be in just one of those tails, okay? And because the calculator loves the left-handed values, let's go ahead and do 0.05, which is already inside the calculator from the last example, coincidentally. And we're going to get a negative 1.64, just like in the last answer. So let's go ahead and write that down. So this guy over here, this cutoff region is going to be negative 1.64. Now, these are symmetrical, right? Do you remember how histograms work? If you have the same area on the left and the right, then over here, it's going to be the same exact value, but positive. And that's this guy over here. That's it. So we have two critical values. They're both going to be the same. We use technology to get them. And that's what you want to stick with, technology, knowing how to use the calculator. Okay, so we have two critical values. It says the lower critical value, which is on your left, is going to be, let me turn off this calculator. That's going to be negative 1.64. And on the right side, we have positive 1.64. All right, nice work. Okay, should we reject or should we not reject? Well, this is the traditional method. Let's see where the test statistic is. The test statistic is negative 0.71. And did you notice I didn't look at the claim number not one time, right? Because they already did the work for us. They gave us the test statistic, and we already we did the work and found the critical value. We only need those two values to test the claim. Okay, so where is the test statistic? The test statistic here is z is equal to negative 0.71. Where is negative 0.71 compared to these two guys? Well, it's not going to be over here. It's definitely a negative number. It has to be somewhere over here to the right, because numbers over here, if it was less than negative 1.61, I mean negative 1.64, it would be like maybe negative 2.5 or something like that over in this direction. But our test statistic is only over here, negative 0.71. So this is another fail to reject. So once again, we're going to fail to reject, which means that we're not going to reject. So HO should not be rejected. So it's either going to be B or C, and it's because it is not in the critical region. And let's see. Yep, let's go ahead and go over these. Okay, we're almost done. So let's see, assume a significance level of alpha equals 0.1, blah, 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 blah. All right, the original claim, the p-value. Okay, so listen, they already gave us the p-value. Once they give you your p-value, you're golden, okay? Because all you have to do is ask yourself if the p-value is less than or greater than your sig level. So your p-value here is 0.0059. Is that less than or greater than your significance level? Yeah, 0.0059 is definitely less, so we're going to reject, all because it's less than that. Okay, so it says without using technical terms. Now, these terms are pretty damn technical to me. That's my opinion. But whatever. Whenever you reject the null, there is enough evidence, okay? Whenever you fail to reject, there is not enough evidence. So there is definitely enough evidence. And it's that one right there. Let me make sure. Yep, that's it. Now, one thing of note, one thing of caution, actually, you see that they're using the words warrant rejection, like over here. Every course is different. I'm not sure the lingo or the what's the word I'm looking for? It's like there's a consistency and statistics between the courses that's kind of lacking, in my opinion. Maybe you can correct me. It seems like the warrant rejection part mostly deals with two-tailed tests, which means that your claim has to say something about equal to. Find out more about that, because I found out that it's not really consistent. You can ask your professor. Maybe your professor would give you a better insight on that. But anyway, let's keep going. Okay, the type 1 error and type 2 error stuff. So it says, which of the following is a type 1 error? The type 1 error is when you reject. Okay, so it's not going to be A or B. It's when you reject and then something else happens. So we're going to reject the claim. So these two portions are identical. You know, we have this over here. We have this over here. When you reject the claim, you're saying that there is enough evidence to support that claim that it is something, right? Normally, but with error, with type 1 error, actually that thing is different than what their claim is. So that's what type 1. Here we go. First mistake. Okay. Type 1 error. You're definitely going to reject, right? When you reject the null hypothesis says is equal to. When you reject that equal to portion, you're saying that it isn't equal to that particular claim. Really, type 1 error basically is the opposite of what we know is to be true. Like when you reject, there is. When you fail to reject, there is not. So just switch your judgment. Let's see if we get the. Let me tell you something. Type 1 and type 2, I struggle with that. Just I want to be honest. Back in the day, I did struggle with that. And I have more of an understanding now, but you can see I'm still getting it wrong. But it's not the end of the world. Just commit it to memory. Keep that in your mind. And remember, I'm more of the mathematics side anyway. Statistics is... Okay, which of the following is a type 2 error? Type 2 error, that's the fail to reject portion. And let's see. You always fail to reject when a portion is actually... If you fail to reject the null, that means you're saying it is equals, but it should not be equal. So it should be this one. Excellent. See, we got it right this time. It's not the end of the world. I promise I will be better. Okay, here's another type 2 error, type 1 error stuff. Let's see if I can redeem myself. I hope I can. Okay, identify the type 1 error. So it's definitely rejecting something. So it's either going to be A or D. So when you reject the null, you're saying it's not equal to, let's see. Okay. All right, that's it. That's the end of the numbers. Yeah. Just with the type 1 and type 2, just study that on your own. Try to get a grasp on that. Remember, mathematics is more straightforward than conjecture and other good stuff. So I will see you in the next video. All right, thank you so much for watching.